So before we can start the problem, we have to know and understand it. Right now I'm drawing a graph to help you better understand how this works. So the red Roman numeral stands for as heat flows, temperature changes. Meaning as heat flows, it gets hotter and turns into water and turns into steam. The blue represents the phase change. So when things get hotter, they turn into a solid into a liquid, or a liquid into a gas. I'll be showing two different equations that will help you solve for each change. So the first formula is the heat formula. The heat formula combines the specific heat, the mass, and the change of temperature to find the heat. I will be showing you what two specific heats that you'll be using for this problem. You'll be using the specific heat of ice and the specific heat of water. You will use these numbers to multiply with the mass and temp to get the heat. This equation is very important for this problem and it will be used again repeatedly. The next two formulas you will be using are the Latin heat of fusion formulas. These formulas are used to help you find the amount of energy needed to change 1 kilogram of material from solid to liquid, or liquid to gas. As you can tell, these formulas will be used to help you find the phase change. The first formula will help you find the phase change of a solid to a liquid. The formula consists of mass times latent heat. Latent heat equals 3.33 times 10 to the 5th power joules over kilogram. The next equation will be how to find the phase change of liquid to a gas. Same concept but different numbers. There should be a E button on your calculator somewhere near it. That is what you will use to calculate the number. Later in the video I will show you how to actually type it in the calculator. Right now I am writing down the two specific heats we will be using for the heat formulas. We will be using the ice one first and then the water next after. The first thing we will be doing is converting negative 54 Celsius to 0 Celsius. This is because 0 Celsius is water. That is when ice melts and starts to melt. So, we have to figure out what numbers goes to which in the heat formula. We know that the mass is 23 kilograms. We will be using the specific heat of ice, which is 2100 joules over kilogram Celsius. And the change of temp, it will be 54 Celsius degrees. Now we will begin to multiply. For multiplication, we will be using unit analysis. Unit analysis, we will be putting all the numbers on top since we're multiplying. Celsius and kilograms are crossed out since they cancel out each other. Now when you multiply 23 times 2154, you get 2,608,200 joules. We'll be using this number for later. Now, since we did a change in temp, there will also be a change in phases. This is our first phase change. Ice into water. We're going to use the Latin heat formula that converts a solid to a liquid. So we know that mass is 23 kilograms and the weight in heat is 3.33 times 10 to the 5th power. The way I put in the 5 is how you should put it on your calculator. You should have a scientific calculator with E. Now, let's do unit analysis. Like before, the kilograms will cancel out. Your number would be 76,590,000 joules. Again, save this number for later. Now, since we changed the ice into water, we will be changing the water into steam. But to get steam, you need 100 Celsius. So there will be another temperature change. So you use the heat formula, put in your numbers, 23 kilograms of mass, but we will be using the specific heat of water, which is 4,180 joules over kilograms Celsius, and change of temp is going to be 100. Now do unit analysis, which is just multiplying across. Like before, they all cancel out, except for joules, and your answer will be 9,614,000 joules. Now, this is the second to last part of the problem. As you see, I already have everything set up, and now I'm doing unit analysis. The kgs, kilograms cancel out, and then you multiply across. Answer will be 519,800,000 joules. The last step of this problem is that you'll add up all the joules that you calculated from the latent heat formula and the heat formula. Once you get your number, that is the answer.